4-speed synchromesh gearbox work. A 4-speed synchromesh gearbox is a type of manual transmission system commonly used in vehicles to allow the driver to manually select different gear ratios to optimize engine performance and vehicle speed. The term synchromesh refers to the mechanism that synchronizes the speeds of the gears before they engage, ensuring smooth and seamless gear shifts. The gearbox consists of several key components, including the input shaft, output shaft, gears, synchronizers, shift forks, and a gear lever. Each of these components plays a critical role in the operation of the gearbox, enabling the driver to shift between neutral, first, second, third, and reverse gears. In neutral, the gearbox is in a state where no gear is engaged, meaning the input shaft, which is connected to the engine via the clutch, is not transferring power to the output shaft, which is connected to the wheels. In this state, the engine can run independently of the wheels, allowing the vehicle to remain stationary while the engine is running. When the driver depresses the clutch pedal, the clutch disengages the engine from the input shaft, and the gear lever is moved to the neutral position. This ensures that no gears are meshed, and the input shaft spins freely without transmitting power to the output shaft. To engage first gear, the driver presses the clutch pedal to disconnect the engine from the input shaft and moves the gear lever into the first gear position. This action activates the shift fork, which moves the synchronizer for first gear. The synchronizer is a crucial component that matches the speed of the input shaft to the speed of the first gear before they engage. This synchronization prevents grinding or clashing of gears, ensuring a smooth transition. Once the speeds are matched, the synchronizer locks the first gear to the output shaft, allowing power to be transmitted from the engine to the wheels. First gear provides the highest torque multiplication, making it ideal for starting the vehicle from a standstill or driving at very low speeds. When the vehicle gains sufficient speed, the driver may shift into second gear. To do this, the clutch pedal is pressed again to disengage the engine from the input shaft, and the gear lever is moved to the second gear position. The shift fork for second gear moves the corresponding synchronizer, which matches the speed of the input shaft to the speed of the second gear. Once synchronized, the second gear is locked to the output shaft, and power is transmitted to the wheels. Second gear provides less torque multiplication than first gear but allows the vehicle to travel at a higher speed while maintaining engine efficiency. The process of shifting into third gear follows the same principles. The driver presses the clutch pedal, moves the gear lever to the third gear position, and the shift fork engages the synchronizer for third gear. The synchronizer matches the speed of the input shaft to the speed of the third gear, ensuring a smooth engagement. Third gear provides even less torque multiplication than second gear but allows the vehicle to travel at higher speeds with reduced engine RPM, improving fuel efficiency and reducing engine wear. When engaged in reverse gear, it is different from forward gears because the output shaft must rotate in the opposite direction. In conventional non-synchronized reverse gears, an idler gear is introduced between the countershaft and the main shaft's reverse gear and the rotation is reversed. However, in a synchronized reverse gear, a synchronizer ring and angle coincide with the main shaft before interacting with the speed of the reverse gear, preventing grinding. When the driver chooses to reverse, the selector fork moves the synchronizer of the reverse gear, ensuring a smooth transition before locking the gear. Unlike forward gears, reverse gear usually has a higher gear ratio similar to first gear, allowing controlled movement at low speeds with high torque. Advantages of a 4-speed synchromesh gearbox. 1. Smooth and easy shifting. Synchronizers ensure effortless gear changes without grinding. 2. No double clutching required. Unlike non-synchromesh gearboxes, drivers don't need to match engine speeds manually. 3. Reduced wear on gears. Synchronizers prevent direct gear collisions, extending gearbox life. 4. Better fuel efficiency. Optimized gear ratios help maintain efficient engine performance. 5. Improved driving comfort. Easier gear selection reduces driver fatigue and enhances the driving experience. Disadvantages of a 4-speed synchromesh gearbox. 1. Limited gear range. 4 gears may not be sufficient for modern high-speed or fuel-efficient driving. 2. Higher manufacturing cost. More components, like synchronizer rings, make it costlier than simpler gearboxes. 3. Slower gear engagement. Synchronizers take time to match speeds, making shifting slightly slower than non-synchronized racing gearboxes. 4. Wear and tear on synchronizers. Over time, synchronizer rings degrade, leading to difficult shifting and repair costs. 5. Not ideal for heavy loads. may struggle with high torque applications compared to constant mesh or manual non-synchronized gearboxes.